Man, Emily, this crystal structure stuff is really hard. What are you doing?
Well, let me explain. Let me go over the basics of 3 different characterization techniques: X-ray diffraction, electron backscatter diffraction, and transmission Kikuchi diffraction. With XRD, you're going to have a sample on a holder, an X-ray source, and a detector. And what will happen is, as your X-ray source is emitting X-rays, it's going to move up closer to your detector, and your detector is also going to move up as well through an angle of theta for a total value of 2 theta because you have both pieces moving. And as those X-rays are hitting your sample and then being collected by the detector, you're going to get an emission spectrum. And essentially what happens is the intensity of all of the X-rays diffracted off of your sample are graphed with their corresponding 2 theta angle. And what your resulting spectrum is going to look like is some small noise at low intensity with a lot of really tall peaks. And those peaks correspond to different orientations within the crystals. So, and we don't just look at the graphs and know immediately, yes, that one peak corresponds to this certain orientation. We have to look at a lot of databases to figure out what it means for a specific type of material. With EBSD and TKD, you're doing something a little bit different, but you're still going to be looking at your crystal phase and orientation. So with EBSD, what happens is you have a bulk sample on a holder that's been polished so that it's really smooth and you have as few defects as possible. You will put that into this fancy machine and it's going to emit a lot of electrons, and the backscattered electrons are going to be collected by an EBSD detector. It's important to note the orientation between your electron beam and the detector along with the sample. It's at an angle of 70 degrees. So what happens is when these electrons hit your sample, they're going to hit at specific atoms, and just depending on where they hit, when they're refracted, they end up creating these little Kikuchi bands on your detector. And we can use some really fancy software or just Bragg's law in general to figure out what those different bands correspond to in terms of orientation. But what happens when these electrons hit your sample is they're going to scatter within the sample. And because they're not all going to scatter perfectly, you're going to have some electrons like going straight through and some going kind of out to the sides, which is not really what you want because it's going to lower your resolution. So what ends up happening is with EBSD, you have a resolution of about 50 nanometers, which is, again, very small, but keep that in mind. Because with TKD, you're going to get a much better resolution of about 10 nanometers, and it's because of the orientation. So instead of with EBSD, where you look at the backscattered electrons, you look at the front scattered electrons. So you'll have the E-beam and your detector and your sample at a different orientation so that it's at negative 20 degrees instead of 70. So again, it's going to do the same diffraction, so you're going to get Kikuchi bands as your resulting image, but because these electrons are coming from the other side, they're going to go much more straight through your sample. So because you don't have all these electrons going out in different directions, that's why your resolution is better.
That's incredible. But I do have a question. Why would you ever use EBSD when you can get higher resolution with TKD?
Well, there are a couple reasons. For one, with EBSD, you're going to have to do some amount of sample preparation. So you have to have a really smooth sample because the electrons are not going to penetrate very far. So if you had a lot of defects, then you're not going to get a really nice diffraction pattern. But with TKD, instead of just having to polish your sample, you have to create these really, really small samples. I'm talking about 250 nanometers thick.
That sounds really small.
It's really small. So that takes a really long time. And you can do that here at State, at the AIF, but it takes about 3 hours to do one sample. So that's kind of why some people are going to choose EBSD over TKD, because they just don't have the time to do it, or they don't really need that good a resolution. 50 nanometers is good enough.
Okay, word. That makes sense. I guess if it's easy.